This video is going to be an updated version to an earlier video that I created on projectile motion. But let's go over some basics. The first thing you need to know are the kinematic equations. At constant speed, d is equal to vt. Displacement is equal to velocity multiplied by the time. Now under constant acceleration, displacement is equal to the average velocity multiplied by time. And the average velocity is basically the average of the initial and the final velocity. You add up the initial and the final and you divide it by 2 if the acceleration is constant. Now you also have some other equations. V final is equal to V initial plus AT. So the final velocity is equal to the initial velocity plus the acceleration multiplied by the time. Also, the square of the final velocity is equal to the square of the initial velocity plus 2 times the product of the acceleration and the displacement. And there's another equation. Displacement is equal to V initial t plus 1/2 AT squared. Now the displacement is the change in position. It can be the final position minus the initial position along the x-axis, or it can be along the y-axis. So if we replace d with y final minus y initial, we can get another equation that perhaps you've seen in your physics course by now, which looks like this. The final position is equal to the initial position plus v initial t plus 1/2 AT squared. Now d can represent displacement, or sometimes you can use it to find distance. Distance and displacement are the same if the object moves in one direction and doesn't change direction. Whenever the object changes direction, displacement and distance are different, so you got to be careful in the way you solve it. But if it's moving in one direction, distance and displacement, they're the same in that case. Now let's say if we have a ball and we're going to kick it off the ground, goes up, and then it's going to go down. Gravitational acceleration is negative 9.8 meters per second squared. For this example, we're going to round it and we're going to use negative 10 just to keep things simple. So let's say at t equals 0, I'm going to put the time inside the ball. Let's say the horizontal velocity, Vx, we're going to say it's 7, and the vertical velocity, Vy, we're going to say it's 30. Now 1 second later, what do you think the horizontal and the vertical velocity will be? And what about 2 seconds later, and then 3 seconds later, and so forth? So 1 second later, I should probably put that in a different color. The horizontal velocity will not change. It's going to remain 7. The vertical velocity will change. And how much will the vertical velocity change by? The vertical velocity changes by the gravitational acceleration. Acceleration tells you how much the velocity changes every second. Since the gravitational acceleration, which is the acceleration in the y direction, it changes about 10 every second, Vy is going to decrease by 10 every second. So 1 second later, it's going to be 20. 2 seconds later, Vx is going to be the same, but Vy is going to be 10. 3 seconds later, Vy is now 0. At the top, it's not going up anymore. You only have horizontal motion, but Vx is still 7. Then Vy becomes negative. But Vx will always remain 7. Because Vx is constant, the acceleration in the x direction is 0. A projectile, by definition, is only under the influence of gravity. So if you throw a pen, once you release it from your hand, it's a projectile. A flying bird is not a projectile. It's in the air, but it has the force generated by its wings acted on it. so it's not a projectile. Projectiles can only have gravity acting on it. Air resistance is ignored. So this is going to be 2, 3, 4 seconds later. Vy is going to be negative 10. 5 seconds later, negative 20. 6 seconds later, negative 30. Now here's a question for you. What is the vertical velocity and the speed 5 seconds later? The vertical velocity, Vy, is negative 20. The speed is positive 20. Speed is the absolute value of velocity. Velocity can be positive or negative. Speed is always positive. Speed is the magnitude of velocity. Speed is a scalar quantity, velocity is a vector. Vectors have magnitude and direction. Scalar quantities only have magnitude only. Now if you notice, because the acceleration is negative, the velocity is always decreasing. On the left side, it goes from 30 to 0, so it's decreasing. On the right side, from 0 to negative 30, it's still decreasing. So the velocity is always decreasing. However, the speed, because it's never negative, it's positive on the left side and the right side. So notice that the speed is decreasing on the left side, but on the right side it's increasing because it goes from 0 to 30. So whenever the ball travels upward, the velocity decreases and the speed decreases. But as the ball begins to fall back down to the ground or towards the earth, the speed increases and the velocity continues to decrease. Make sure you understand that. Now there's 3 types of trajectories that you need to be familiar with. So here's the first one. Let's say if we have a ball that rolls off a cliff and it falls down. H represents the height of the cliff. R is the range, which is the horizontal distance between the base of the cliff, which is here, and where the ball lands. Now, because it's moving horizontally, initially, the initial speed is Vx and not V. Well, V and Vx are the same, but the initial speed is Vx. At the top, whenever it's moving horizontally, Vy is equal to 0, as in the case of the other problem. So you can easily find the height using this equation. H equals 1/2 at squared. It comes from this equation. Now, because height is a vertical displacement, everything in this equation that we use has to be in the y direction. So we need to use dy, vertical displacement, Vy initial, times t plus 1/2 ay t squared. Now, dy is basically the height. At the top, Vy is 0, so this term disappears, and so you get this equation. So make sure you know this equation. H equals 1/2 at squared. It's very useful for this type of trajectory. Now, if you wish to calculate the range, it's equal to Vxt. Remember, we said that whenever an object moves with constant speed, d is equal to Vt. Now, Vx is V cosine theta, and Vy is V sine theta. It's based on this triangle. Here's V, Vx, and here's Vy, and here's the angle theta. Now, according to SOHCAHTOA, perhaps you've seen this if you've taken trig, S stands for sine. Sine theta is equal to O, and H stands for opposite and hypotenuse. So sine theta is the ratio between the side that's opposite to theta, which is Vy, divided by the side that's the hypotenuse, which is across the box, and that's V. Cosine theta is equal to the adjacent side, Vx, divided by the hypotenuse of V. Tangent theta is equal to the opposite side, which is Vy, divided by the adjacent side, Vx. So from this equation, if you multiply both sides by V, you can see that Vy is V sine theta. Now for the second equation, if you do the same thing, Vx is V sine theta. Now for the third equation, it's useful to calculate the angle. If tangent theta is Vy over Vx, then the angle theta is the inverse tangent of Vy divided by Vx. Now according to the Pythagorean theorem, there's one more equation that we can write. Since Vx, Vy, and V are all the three sides in a right triangle, and according to the Pythagorean theorem, c squared equals a squared plus b squared, v squared is equal to vx squared plus vy squared. Therefore, v is the square root of vx squared plus vy squared. If you need to find a final speed just before it hits the ground, this is the equation that you'll need. Now let's talk about the second trajectory that you'll see, which occurs when a ball is kicked off from the ground. It goes up and then goes back down. This is going to be the height, or the maximum height of the trajectory, and the horizontal distance is the range. Let's call this point A, B, and point C. Now, if you need to find the time it takes to go from point A to point B, it's equal to V sine theta divided by G. In another video, I show you how you can derive these equations. Now, the time it takes to go from, let's say, A to C is simply twice the value from A to B due to the symmetry of the graph. So you get this equation. Now, the maximum height is equal to V squared sine squared theta divided by 2G. The range is equal to V squared sine 2 theta divided by G. So because the velocity, the ball is kicked at an angle, you're going to be given V instead of Vx or Vy. And the angle relative to the horizontal is theta. So typically in a problem like this, you'll be given the initial speed and the angle, and you can find anything you need based on these equations. Now the other equations still apply. Now it's important to understand that the speed at part A, or at point A, is the same as the speed at point C. If you recall, when I went over the trajectory that looks like this, with all the speeds every second, the speed 1 second later was equal to the speed that occurred at the same height. I think in the last example, 1 second later, the vertical speed was 20, and on the right side, the vertical velocity was negative 20, which means the speed was also 20. 2 seconds later, we had 10 and 10. But as you can see, whenever you have 2 points at the same height, the speed will be the same. So if you need to find the final speed at point C, it's the same as the initial speed at point A. Just keep in mind, at point A, the vertical velocity is positive, but at point C, it's negative, but the magnitudes are the same. Now, the last trajectory that you need to be familiar with looks like this. Typically, you have a ball at a cliff or at a building, and it's kicked off at an angle. It goes up, and then it goes back down. So all of the equations that you've seen before, you can apply it to this trajectory. Now, in addition to the other equations, one equation that might be useful is this equation. Y final equals Y initial plus Vy initial t plus 1/2 AT squared, or AYT squared, where AY is negative 9.8. Y initial is basically the height of the cliff. And if you want to find the time it takes to hit the ground, that is at point C, Y final, replace it with 0, and then use the quadratic equation to get the answer. Now typically you'll be given the velocity v and the angle theta. So to find Vy is V sine theta, so just keep that in mind. Now, to use the quadratic formula, make sure you have a 0 on one side of the equation. T is going to be equal to negative b plus or minus the square root b squared minus 4ac divided by 2a. Now, if you don't want to use the quadratic formula to find the time it takes to go from a to c, you could find the time it takes to go from a to b and add it from b to c. The time it takes to go from a to b, we have that formula. It's going to be 2v sine theta. Actually, we found the 2. It's v sine theta over g. And to find the time it takes to go from b to c, use this equation. You may need to find the height between a and b. But if you look at the right side of the graph between b and c, you can use the fact that h plus y initial, that's the total height relative to the ground, is equal to 1/2 at squared. And if you solve for t, that's going to give you the time it takes to go from b to c. Then you add up these two values, and you should get this answer. Now, another thing that you may need to know is you need to calculate the speed just before it hits the ground. So Vx is constant. It's going to be the same at point A, B, and C. However, Vy changes. So first, you need to find Vy final at point C, using Vy initial at point A. Once you have Vy final and you already know Vx, you could find Vx by using this equation. You can calculate the final speed of the ball just before it hits the ground using this formula. And to find the angle, use this. It's inverse tangent Vy divided by Vx. To find the maximum height, or the height between point A and B, you can use this equation. It's v squared sine squared over 2g. Now let's work on some problems. A ball rolls horizontally off a cliff at 20 meters per second. It takes 10 seconds for it to hit the ground. Calculate the height of the cliff and the horizontal distance traveled by the ball. Now the first thing we need to decide is which of the three common trajectories do we have. So the ball starts off on a cliff and it rolls horizontally, so it's going to the right, and eventually it's going to fall down. So this is the type of trajectory that we have in this problem. Next, make a list of what you have. We have the speed of the ball as it leaves the cliff. Since it's traveling horizontally, we have the speed Vx. So Vx is equal to 20 meters per second. Now it takes 10 seconds for it to hit the ground, so we have the time. Calculate the height of the cliff, that's h, and the horizontal distance traveled by the ball, which is the range. To find the height of the cliff, we could simply use this equation. H is equal to 1/2 at squared. Now a, we can use 9.8. If you use negative 9.8, h is negative, but what it really means is that the vertical displacement is negative because the ball is going down. But for all practical purposes, we want the height to be positive, so let's plug in positive 9.8. And t is 10. Half of 9.8 is 4.9. 10 squared is 100. So 4.9 times 100 is 490. So that's the height of the cliff, since it takes 10 seconds to hit the ground. Now let's calculate the range. The range is equal to Vxt. And we know Vx is v cosine theta, but we already have Vx, which is 20. So therefore the range is going to be 20 meters per second multiplied by 10 seconds. And you can see that the unit seconds will cancel. 20 times 10 is 200. So the range is 200 meters. And that's it for this problem. A ball rolls off a cliff that is 200 meters high. Calculate the time it takes for the ball to hit the ground. So for this problem, we have a similar trajectory. It rolls off the cliff, and then it hits the ground. And our goal is to find the height. And we know that the height is 1/2 at squared. Actually, we have the height. Our goal is to find the time it takes to hit the ground. The height is 200. The acceleration is 9.8. And let's solve for t. So half of 9.8 is 4.9. To isolate t squared, we need to divide both sides by 4.9. 200 divided by 4.9 is about 40.8163, and that's equal to t squared. So now we need to take the square root of both sides to get t. And so t is going to be 6.389 seconds. And so that's how long it's going to take for the ball to hit the ground. A ball is released from rest and drops straight down, starting at a height of 800 meters. How long will it take to hit the ground? Now, what if the ball was thrown straight down with an initial speed of 30 meters per second? How long will it take to hit the ground now? So let's draw a picture. So let's say this is the ground level. And here we have a ball. And we're throwing it down. Well, for the first one, it's going to be released from rest. And it's going to fall straight down. What is the initial speed if it's released from rest? Now, there's no Vx component because it's not moving to the left or to the right. It's falling straight down. So initially, Vy is equal to 0. If it drops down, being released from rest. Now, in the other example, Vy is not 0. The ball was thrown straight down. So Vy is negative 30. The speed is positive, but the velocity is negative because it's going in the negative y direction. In each case, the height is 800 meters. So what can we do to find the time it takes for it to hit the ground? In the first example, you can simply use the equation h is equal to 1/2 at squared. H is 800. The acceleration is 9.8. And we can solve for t. Half of 9.8 is 4.9. 800 divided by 4.9. That's 163.265. And that's equal to t squared. So now we can take the square root of both sides to get t. So t is 12.78 seconds. Now what about part B? How can we find the time it takes for it to hit the ground if there's an initial speed? So recall that this equation comes from this expression. dy is equal to Vy initial multiplied by t plus 1/2 ay times t squared. Now we need to be careful with the way we are going to use this equation. We're going to put the negative signs in the problem. So we have to be careful. Using this equation, we didn't have to worry about the negative signs. Now the ball is traveling 800 meters in the negative y direction. So the vertical displacement is negative 800. We do have an initial velocity in the y direction. It's negative 30. So we need to take that into account. And then we have plus 1/2. Ay, the acceleration in the y direction, is negative 9.8. So this is going to be negative 4.9 t squared. Now let's move everything from the right side to the left side. So this is going to be positive 4.9 t squared on the left side plus 30t, and the 800 is going to stay on the left side, so it's still negative 800. As you can see, we have a quadratic equation in standard form. To solve for t, we need to use the quadratic formula. So let's make some space first. So here's the quadratic formula. T is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. So a is 4.9, b is 30, c is negative 800. So this is going to be negative 30 plus or minus square root. 30 squared is 900, and then this is going to be minus 4 times a, which is 4.9, times t squared, times c, which is negative 800, divided by 2a, or 2 times 4.9, which is 9.8. So now let's multiply these three numbers. Negative 4 times 4.9 times negative 800, that's equal to positive 15,680. And we still have a 900 next to it. So now let's add those two numbers. If we add 900, it's going to be 16,580, and the square root of that number is 128.76. Now, there could be two answers. Negative 30 minus 128.76 and plus 128.76. We know time can't be negative, so we're just going to ignore the negative answer. So, if we take negative 30 plus 128.76, that's positive 98.76, and divided by 9.8, this will give us a t value of 10.08 seconds, which is less than the other answer, which was 12.78. Because in the second example, the ball was thrown towards the ground, it's going to take a shorter time to get to the ground, since it was given that initial speed. And so it makes sense why it would be less. Now we could check the answer. If you plug it into the original equation, we need to make sure that we get 0. 4.9 times 10.08 squared plus 30 times 10.08, that's 800.27 minus 800, that's approximately 0. So this answer is correct. A ball is kicked horizontally from the roof of a building that is 300 meters tall and lands about 400 meters from the base of the building. So let's begin by drawing a picture. So it travels horizontally from the roof of the building, then it's going to fall down. Now we have the height of the building, that's 300 meters, and we have the range, which is 400 meters. The range is the distance between the base of the building and where it lands. Now we need to find the initial speed Vx. We can use the range equation to find it. The only thing we're missing is the time, but we could find the time using this equation. So let's calculate the time it takes to hit the ground first. So the height is 300, A is 9.8, half of 9.8 is 4.9. So 300 divided by 4.9 is 61.22. And so that is equal to t squared. So don't forget to take the square root of both sides. And so t is equal to 7.82. So now that we have the time, we could find Vx. using the other equation. The range is 400 and t is 7.82. So 400 divided by 7.82 will give us the initial speed, Vx, which is 51.15 meters per second. So now that we have that, we could focus on the rest of the problem. So part B, calculate the final speed of the ball just before it hits the ground. We have the speed of the ball at position A. We need to find it at position B. Now keep in mind, Vx is constant, it doesn't change. So at position B, Vx is still 51.15. We need to find Vy. At position A, Vy is equal to 0. But at position B, it's not going to be 0. So to find the Vy value at position B, we need to use this equation. So Vy initial, that is at position A, is 0. The acceleration in the y direction is negative 9.8, and the time is 7.82 seconds. So negative 9.8 times 7.82, that's equal to negative 76.636. Now that we have Vx and Vy, we could find V, the final speed just before it hits the ground, using this equation. So V is going to be the square root of Vx squared, which is 51.15 squared, plus Vy squared, which is 76.63 squared. You don't have to worry about the negative sign because once you square it, it's going to be positive. And so what I got for V is 92.14 meters per second. So now that we have the value of V, we can find the angle. So that's the answer to part B. Now let's move on to part C. To find the angle, this is going to be inverse tangent Vy. We're going to use the positive value of Vy, 76.636, divided by Vx, which is 51.15. So if we type this in, inverse tangent you should get an angle of 56.3 degrees. Now just double check and make sure your calculator is in degree mode. Now let's draw this. So let's say here's the coordinate system, and at the center we have the ball. The ball has an x component that is 51.15, and it has a y component of negative 76.6. And so the velocity vector is here. The angle that we got is this angle. So basically, it's 56.3 degrees below the x-axis. Now measured from the positive x-axis, that's 360 minus 56.3, which is 303.7 degrees. Going counterclockwise. But traveling clockwise, it's 56.3 or negative 56.3, since that's below the x-axis. And that's it for this problem. What angle between 0 and 90 will yield the maximum range of a projectile? It turns out that an angle of 45 degrees will produce the maximum range. Now what about the second problem? What angle would yield the same range if the ball is launched at 20 degrees. An acute angle is basically an angle between 0 and 90. To get the same range as 20, you need to launch the angle at 70, because those two angles are complementary. Whenever two angles add up to 90, those two angles will have the same range. So if you launch it at 10, it will yield the same range as 80, because 10 plus 80 is 90. If you launch it at 30, it will yield the same range as 60. A ball is kicked from the ground at a speed of 40 meters per second and at an angle of 30 degrees. Calculate the horizontal and the vertical velocity and even the acceleration components when the ball was kicked, that is at position A, and when it reaches its maximum height at position B. So how can we do that? Let's focus on position A, when it was kicked. Vx is simply V cosine theta. So that's 40 cosine 30. And you could just type this in. 40 cosine 30 is about 34.6 meters per second. To calculate Vy at point A, it's V sine theta, so it's 40 sine 30. Sine 30 is a half. Half of 40 is 20. The acceleration in the x direction for any projectile is always 0, by definition. The acceleration in the y direction is always negative 9.8 due to free fall, due to gravitational acceleration. Now at point B, Vx will remain the same. Vx doesn't change. So it's going to be 34.6 meters per second. Now Vy does change. At point B at the top, Vy is always 0. The acceleration in the x direction is always 0. And in the y direction, it's going to remain negative 9.8. And so that's it for this problem. Now if you need to find it at point C, Vx is going to be the same, 34.6. Ax and Ay will not change. The only thing that changes in this graph is Vy. Now Vy initially was 20 at point A. At point C, it's negative 20 because it's going down. But because, due to the symmetry of the graph, the magnitudes of these two will be the same at point A and point B. Only the sign is different. A ball is kicked off the ground at 40 meters per second at an angle of 60 degrees. So the trajectory that we have in this problem looks like this. It's symmetrical. Part A, find the maximum height. So we got to calculate h. Now we have the speed of the ball. It's 40 meters per second, and it's at an angle of 60 degrees. We can use this equation to find the maximum height. It's v squared sine squared theta divided by 2g. So that's going to be 40 squared times sine of 60 degrees and then squared divided by 2 times 9.8. So let's take it one step at a time. Sine 60 is root 3 over 2, and when you square it, you get 3 over 4. 40 squared is 1600. 2 times 9.8 is 19.6. 1600 times 3 over 4 is 1200. And 1200 divided by 19.6 is 61.2. So that's the height. Now let's move on to part B. Let's find the time it takes to hit the ground. That is, the time it takes to go from A to C. The total time is going to be 2v sine theta divided by g. So that's going to be 2 times 40 times sine of 60 divided by 9.8. So 2 times 40 is 80. 80 sine 60 is 40 root 3, or 69.28. And if you divide that by 9.8, you should get 7.07 seconds. So that's the time it takes to go from position A to position C. Now what about the last part, the range of the ball? We can use this equation. It's v squared sine 2 theta divided by g. So v squared is 40 squared, and theta is 60, so 2 theta is 120 divided by 9.8. Sine 120 is root 3 over 2 times 1600, that's 1385.6 divided by 9.8. And so the answer to part C is 141.39 meters. And that's it for this problem. Now I do want to mention something, and that is you can find a range using this equation, Vxt. And keep in mind, Vx is v cosine theta. So if we multiply 40 cosine 60 times t, which is 7.07, notice what we'll get. Cosine 60 is a half. Half of 40 is 20. 20 times 7.07 is about 141.4. So you get the same answer. Now this is a rounded answer, so if you use the exact answer, you should get 141.39. So that's another way in which you can calculate the range. So keep this in mind. This equation is only useful for a symmetrical trajectory. However, you can always use this equation for any trajectory. As long as you have Vx in a time, that's going to equal the range. A ball is thrown straight up with an initial speed of 50 meters per second. How high will it go? So it goes up and then it goes down. Now the equations that you need for this problem are the same equations that you would use for this problem. It's the same as if it's kicked at an angle, but when it goes straight up, the angle is 90 degrees. 90 degrees is the positive y-axis. So therefore, knowing that, we can calculate the height using the same equation as the last problem. That is v squared sine squared theta divided by 2g. So v is 50 times the square of sine 90 divided by 2 times 9.8. Sine 90 is 1. 1 squared is still 1. 50 squared is 2500. 5 times 5 is 25, and just add the 2 zeros. 2 times 9.8 is 19.6. So now, all we need to do is just divide these two numbers. And so the maximum height attained by the ball is 127.55 meters. Now, how long will the ball remain in the air? To get that answer, we can use this equation. 2v sine theta divided by g. So it's 2 times 50 and sine 90, which is 1, divided by 9.8. So basically, it's going to be 100 divided by 9.8. And so the time of flight is 10.2 seconds. And that is it for this problem. A ball is kicked off the ground, reaching a maximum height of 100 meters, and lands 200 meters away. Calculate the initial speed v and the angle above the horizontal of the ball when it was kicked. So we have a trajectory that looks like this. And we're given the height, which is 100 meters, and we have the range, which is 200 meters. We need to find the angle theta and the speed of the ball v. How can we do that? Well, we know that the height is equal to v squared sine squared theta divided by 2g. And the range is v squared sine 2 theta over g. Now keep in mind, if you take in trig, the double angle formula sine 2 theta is equal to 2 sine theta times cosine theta. So what we're going to do is we're going to divide the height equation by the range. And so we're going to get an expression that looks like this. V squared sine squared theta over 2g divided by v squared. I'm going to replace sine 2 theta with 2 sine theta cosine theta over g. Now in this equation, notice that v squared cancels. In addition, we could cancel a g and we can cancel a sine. So what we have left over is we still have a sine on top because it was sine squared, and then there's a 2 divided by 2 cosine theta over 1. Now, perhaps you heard of the expression keep, change, flip, but before we use that expression, let's clear away a few things. First, let's rewrite the complex fraction like this. This is equivalent to sine theta divided by 2 divided by 2 cosine theta over 1. Now using the expression keep, change, flip, keep the first fraction the same, change division to multiplication, and flip the second fraction. So now we can see that h over r is equal to sine theta divided by 4 cosine theta. Sine over cosine is tangent. So basically it's 1/4 tangent theta. Now solving for tangent, if we multiply both sides by 4, we can see that tan theta is equal to 4h over r. You may want to add this to your list of equations. So if you know the height and the range, you can now find the angle. So let's go ahead and use that. Now if tan theta is 4h over r, theta is going to be the arctan or the inverse tangent of 4h over r. So in this case, it's going to be 4 times the height, which is 100, divided by the range, which is 200. So 400 divided by 200 is 2. So the arctan, or inverse tan of 2, will give us an angle of 63.43 degrees. So now that we have theta, we can now calculate the speed. Now we know that range is equal to v squared sine 2 theta over g. Solving for v squared, we need to multiply both sides by g over sine 2 theta. If we do that, on the right side, these two will cancel, and also those two. And so rg divided by sine 2 theta will equal v squared. So v is basically the square root of rg times sine 2 theta. So if you have the range and you know the angle, you can calculate the speed. The range is 200, g is 9.8, theta is 63.43. So 2 theta, or 2 times 63.43, is 126.86. (200 times 9.8 is 1960, divided by sine 126.86. That's about 2449.7. And if you take the square root, you'll get the speed, which is 49.5 meters per second. And that's it. A golf ball is hit at an angle of 30 degrees and travels 130 meters. What was the initial speed of the ball? So the range is 130 and the angle is 30. And our goal is to find v. So we could use the same equation that we did in the last example, where v is the square root of rg divided by sine 2 theta. So this is going to be r, which is 130, times g, which is 9.8. And if theta is 30, 2 theta is 60. 130 times 9.8 is 1274. Divided by sine 60, that's 1471. If you take the square root of that, you'll see that the final speed is 38.4 meters per second. And so that concludes this problem. A runner jumps off the ground at a speed of 8 meters per second. At what angle did he jump from the ground if he landed 3 meters away? So we can see that in this problem, the range is 3. We have the initial speed, which is 8, and we're looking for theta. So we can use this equation. R is equal to v squared sine 2 theta divided by g. So if we multiply both sides by g, we will get this expression. And if we divide by v squared, we can see that rg divided by v squared is equal to sine 2 theta. Now we're going to take the arc sine of both sides. The arc sine of sine 2 theta is simply 2 theta. So if we divide both sides by 2, we could see that theta is going to be equal to 1/2 arc sine rg divided by v squared. So now let's calculate the angle. So it's 1/2 arc sine, r is 3, g is 9.8, the velocity is 8, so 8 squared is 64. 3 times 9.8 is 29.4 divided by 64. That's 0.459375. And then if you take the arc sine of that value, that's 27.3468. And then if you multiply that by 0.5, theta is equal to 13.67 degrees. And so that's the answer to this problem. So that's how you could find the angle if you have the range and the initial speed. Let's work on this problem. A ball is kicked from a 200-meter cliff at a speed of 60 meters per second at an angle of 30 degrees. Find the maximum height of the ball above the ground. So this time we have the third trajectory, where a ball starts from a cliff and it's kicked off at an angle. It goes up, then it goes down. So we have the height of the cliff. It's 200 meters. We have the angle, which is 30 degrees. And we have the speed of the ball, which is 60 meters per second. Now we want to find the maximum height above the ground. So we need to find this displacement. How can we do that? Well, let's define our points. Point A, point B, and point C. We have an equation that can help us define the vertical displacement between points A and B. If you recall, we can use this equation. H is equal to V squared sine squared theta divided by 2g. So we have the velocity, it's 60, and the angle is sine 30. Let's not forget to square it. Divided by 2g, 2 times 9.8 is 19.6. Now we know that sine 30 is a half. 0.5 squared is 0.25, or 1/4. 60 squared is 3600. 1/4 of 3600 is 900, divided by 19.6. So the height is about 45.92. So that's the vertical displacement between points A and B. The maximum height above the ground is the vertical displacement between points B and C. So that's the sum of 45.92 plus 200. So the answer for part A is 245.92 meters. Now let's confirm that answer. Let's use another method to get the same answer. So first, let's write an equation that gives us the height above the ground at any time t. So we can use this equation. Y initial is the height of the cliff, which is 200 meters. Vy initial is V sine theta, where V is 60 meters per second times sine of 30 times t. And then this is going to be plus 1/2. The acceleration in the y direction is negative 9.8, and then times t squared. So the height above the ground at any time t is equal to this equation. It's negative 4.9 t squared, that's 1/2 of 9.8. Now sine 30 is a half, and half of 60 is 30. So this is plus 30t, and then plus 200. So that gives us the height of the ball at any time t. Now basically, this formula is a downward parabola. And to find the vertex, you've learned in algebra that you could find it using this equation. T is equal to negative b over 2a. That gives you the time it takes to reach the maximum height. Let's find that value. So keep this in mind. A is negative 4.9, B is 30, C is 200. We have a quadratic equation in standard form. So T equals negative B, or negative 30, divided by 2A, where A is negative 4.9. So this is basically 30 divided by 9.8. So this gives us the time it takes for it to reach the maximum height, which is 3.06 seconds. You can also use this equation to find that time. You can use the v sine theta divided by g. That's 60 sine 30 divided by 9.8. And that will also give you 3.06 seconds. So now that we have the time it takes to reach the maximum height, if we plug in t in this equation, we'll get the height at position B. So let's go ahead and do that. Let's clear away a few things. So y final is going to be equal to negative 4.9 times 3.06 squared plus 30 times 3.06 plus 200. So you could just type this in exactly the way you see it. And you get the same answer, which is 245.92 meters. So that's how you could find the maximum height using this process. So you have two different ways in which you could find it. Now what about part B? How can we find the time it takes for the ball to hit the ground? Now keep in mind, we already have the time it takes for the ball to go from position A to position B. At that time, we know it's about 3.06 seconds. Now, if we could find the time it takes to go from B to C, then we can add those two values and get the total time. So notice that from B to C, we have this trajectory. It's the same trajectory where the ball simply rolls off the cliff and hits the ground. And in that case, we can use h is equal to 1/2 at squared. In this case, we need to use the total height from B to C, which we have in part A. So h is equal to 1/2 at squared, and that h is 245.92. Half of 9.8 is 4.9 times t squared. So 245.92 divided by 4.9, and then take the square root of that result. So t is 7.08. That's the time it takes to go from B to C. So therefore, the total time it takes to hit the ground is the sum of these two values. So 3.06 plus 7.08, the total time is 10.1 seconds. Now, can you come up with another way in which we can get that same answer? The other way to get that same answer is by using the quadratic formula. So once you have the position, or rather the height of the ball at any time t, once you have this formula, you can use it to find the time it takes for it to hit the ground. Once it reaches the ground, y final is 0, since there's no height. So therefore 0 is equal to this equation. And whenever you have a 0 on one side, you can solve for t using the quadratic formula. So t is going to be negative b, where b is 30, plus or minus the square root of b squared. 30 squared is 900, minus 4 times a, which is negative 9.8, or rather 4.9, times c, which is 200, divided by 2a, or 2 times negative 4.9, which is negative 9.8. So we have negative 30 plus or minus square root 900. Now negative 4 times negative 4.9 times positive 200, that's 3920. 3920 plus 900 is 4820, and the square root of 4820 is 69.43. Now there's two possible answers. We can do negative 30 minus 69.43 divided by negative 9.8. That result is going to be positive. We have a negative on top and a negative on the bottom. Now if we do negative 30 plus 69, that's a positive answer on top divided by a negative value on the bottom. We don't want a negative time value, so we're not going to use that. So it's going to be negative 30 minus 69.43, which is negative 99.43, and then let's divide that by negative 9.8. If you do that, you'll get a time value of 10.146 seconds, which you can round it to 10.1 if you want. So that's another way in which you can get the same answer. So that's it for part B. So now let's move on to part C. Find the horizontal and vertical components of the ball's velocity just before it hits the ground. Now keep in mind Vx is constant. So Vx is going to be the same at position A and position C. To find Vx, it's simply V cosine theta. V is 60 and theta is 30. So it's 60 cosine 30. And this is going to be 30 root 3, which is 51.96 meters per second. Now Vy changes. We need to find Vy at point C, but we got to find Vy at point A first. So let's use the initial speed of 60, and we're going to use sine 30. Vy is V sine theta. Sine 30 is a half, half of 60 is 30. So this is Vy at point A. Now we got to find it at point C. So let's use this equation. Vy final equals Vy initial plus AT. So Vy initial is going to be Vy at point A, which is 30. Acceleration is negative 9.8. And the time it takes to go from A to C, we got that answer as being 10.14 seconds. So let's calculate Vy final. So that's going to be negative 69.37 meters per second. So that's the horizontal and vertical components of the ball's velocity. The vertical component is negative 69.37. The horizontal component is 51.96. Now, let's find the final speed and the angle of the ball. To find the final speed, you can use this equation. So it's going to be 51.96 squared plus 69.37 squared. Don't worry about the negative sign. So you should get 86.67 meters per second for the final speed. Now let's talk about another way in which we can get that same answer. A method that's actually a lot faster. And it has to deal with the conservation of energy, which you're going to learn in a later chapter, but because it's so useful, I think it's worthy of mention. Now, any object that is above ground level has the potential to fall, so it has potential energy. At position A, the ball has potential energy because it's above ground level. Any object that is at some height above the ground has potential energy. Now, any object in motion has kinetic energy. Potential energy is the product of the mass times the gravitational acceleration times the height. Kinetic energy is 1/2 times the mass times the square of the speed. Now, at position A, the ball has potential and it has kinetic energy because it's moving. Now, position C, it's at ground level, so it doesn't have any potential energy. It no longer has the potential to fall, but it still has kinetic energy just before it hits the ground. So mgh plus 1/2 mv initial squared is going to be equal to 1/2 mv final squared. So notice that we could divide both sides by m. So now all we got to do is plug in the data and solve for the final speed. G is 9.8. The height of the cliff is 200 plus 1/2 the square of the initial speed. The initial speed is 60. And this should equal 1/2 the square of the final speed. So 9.8 times 200 plus half of 60 squared. Let's not forget to square this. 60 squared is 3600. Half of that is 1800. So 1960 plus 1800 is 3760. Now we need to multiply both sides by 2. 3760 times 2 is 7520. And the square root of 7520 is 86.7 meters per second. So notice that we get the same answer. Now let's calculate the angle. So this part is going to be pretty straightforward. The angle is the arctan of Vy, which the magnitude of Vy is 69.37, divided by Vx, which is 51.96. Again, don't worry about the negative sign. So the angle is 53.2 degrees if you round it. So the ball is moving towards quadrant 4. And so it's 53.2 degrees below the horizon, or below the x-axis. Or if you want the other angle, it's 360 minus 53.2, which is positive 306.8 degrees. And so that's it for this problem. Hopefully you found it to be useful. A ball is launched from a 300-meter cliff and lands 380 meters away from the base of the cliff in 9 seconds. Calculate the initial speed and the angle of the ball when it was launched. So once again, we have the same trajectory as in the last problem. The ball was launched from a cliff at an angle. Now we have the height of the cliff, which is 300 meters, and we have the range, which is 380. We also know the time it takes for the ball to go from position A to position C. The total time is 9 seconds. How can we use this information to calculate the initial speed of the ball and also the angle? Well, if we could find Vx and Vy, we can use this equation to get the initial speed of the ball. We got to find Vx and Vy at position A. Now once we have Vx and Vy, we can find the angle using this equation. So our goal is to find Vx and Vy at position A. Once we have that, we can find V and theta. The question is, how do we do that? Well, first, we could find Vx using this equation. The range is 380, and the time to go from A to C is 9 seconds. So 380 divided by 9 is 42.8 42.2 meters per second. Now, how can we find Vy? What equation should we use? Let's focus on position A to position C. So A is the initial position, C is the final position. Notice that the displacement from A to C is a change of 300 meters. Because the ball is going down, we could say that dy between A and C is negative 300. Now the acceleration in the y direction is always negative 9.8. And the time it takes to go from A to C is 9 seconds. What we need to find is Vy initial at point A. What equation has the displacement, the velocity, the acceleration, and the time? The equation that we need is this one. D is equal to V initial t plus 1/2 at squared. But we need to use it in the y direction, along the y-axis. So dy, the vertical displacement, is negative 300. We need to find Vy initial. The time it takes to go from A to C is 9 seconds. And A is negative 9.8. So now what we need to do is solve for Vy initial. Now let's keep in mind Vx is 42.2. So continuing with the equation that we have below, this is what we now have. Half of 9.8 is 4.9 times 9 squared, or 81. That's 396.9. So if we add 396.9 to both sides, negative 300 plus 396.9 is equal to 96.9. 96.9 divided by 9 will give us Vy initial, which is about 10.77 meters per second. So now that we have Vx and Vy at position A, we can now find V. So it's going to be Vx squared plus Vy squared. And that's going to be about 43.55 meters per second. So now the last thing that we need to do is find the angle. So it's going to be arctan Vy divided by Vx. And so that's going to be 14.31, or just 14.3 degrees. And so that's the angle. And here's the speed. And so that's basically it for this video. By the way, if you want to find more physics videos, just check out my channel and look for the physics video playlist. I also have playlists on other topics like algebra, trig, pre-cal, calculus, even general chemistry and organic chemistry. So feel free to take a look at those, and I wish you well on your next exam and have a great day.